Hello, welcome to this video for the 2016 Level 3 Differentiation paper for Level 3 Calculus. So question 1, differentiate y equals to 1 plus x minus 1 over x plus 1 over x squared. Alright, for this question, since we only have x in the denominator, we can move x to the numerator and make it a negative power. So we can rewrite this equation as y equals to 1 plus x minus x to the power of negative 1 plus x to the power of negative 2. And afterwards, we could just use the power rule to differentiate. So dy over dx equals to the constant 1, it goes away. X differentiation of x is just 1. Negative 1 times of, so negative times of negative 1 is a positive, so it becomes plus 1 times of x to the power of negative 2. Because we take the power down by 1, so plus x to the power of negative 2. Negative 2 times of positive, that's a negative 2. So negative 2, take the power down by 1, so x to the power of negative 3. And dy over dx equals to 1 plus 1 over x squared minus 2 over x to the power of 3. And that will be our final answer for this question. And this is simply just an achieved question here. Question B. The height of a tide at a particular beach today is given by the function height of t equals to 0.8 sine of bracket 4 pi over 25 times of t plus pi over 2. H is the height in water relative to the mean sea level, and t is the time in hours after midnight. At what rate was the height of the tide changing at the beach at 9 a.m. today? So this question is just basic differentiate and substitution question because we want to find the rate of change of the height, and we're given the height function as 0.8 sine of 4 pi over 25 times t plus pi over 2. Okay, so differentiate this, we're going to be using the chain rule. Okay, so in this case, the chain rule, we're going to have our outer function, which is sine, and our inner function is everything inside, which is 4 pi over 25 times t plus pi over 2. So we'll write down our function again. We'll say h of t equals to 0.8 sine of 4 pi over 25 times of t plus pi over 2. Is that right? Yeah. Alright, so we know sine differentiates to cos. Okay, so h dash of t equals to 0.8 cos of 4 pi over 25t plus pi over 2. But we cannot forget we have to multiply it by the derivative of the inner function, which in this case is just 4 pi over 25. Alright, and that will be our differentiated function. And what rate was the height of the what was the rate of change of the height of the tide at 9 a.m.? So it says, the question tells us that h is the height of waters relative to mean sea level, and t is the time in hours after midnight. So midnight is at 12 a.m. and it says what was the rate of change at 9 a.m. So 9 hours has passed. So our t value in this case is going to be equal to 9. Okay, so h dash of 9, that equals to 0.8 cos of 4 pi times 9 is 36 pi over 25 plus pi over 2 times of 4 pi over 25. And all we need to do is just plug our numbers into our calculator. Remember to put your calculator on radians when you're dealing with calculus. So radians and cos of 36 times 1. We should get our answer is equal to 0.395. And the unit in this case is the height is measured in meters and time is in hours. So we're going to say meters per hour. Alright, and that should be another achieved question here. So it's just an achieved grade. Question C. A curve is defined by the parametric functions x equals to 2 cos 2t and y equals to tan squared t. Find the gradient of the tangent of the curve at the point where t equals to pi over 4. Alright, so in this case, it says the gradient, so we need to find dy over dx, and all we need to do is substitute t equals to pi over 4 to find the gradient. Alright, so for parametrics, okay, we have x relating to a variable, which is t, and y relating to a variable, which is t, okay? So the first step here, we have to differentiate both x and y with respect to t. So dx over dt, that's going to be using, so to differentiate 2 cos 2t, we're going to be using the chain rule. So the chain rule, so cos is the outer function, 2t is the inner function in this case, okay? So cos differentiates to negative sine, so dx over dt equals to negative 2 sine of 2t, multiplied by the derivative of the inner function. Derivative of 2t is just 2, so multiply by 2. For dy over dt, so tan squared t, we can use the chain rule. Okay, so we take the power down, so it becomes 2 tan t multiplied by, because tan t, because we take the power down by 1, 2 minus 1, the power becomes 1, and we need to multiply by the derivative of tan t, which is sec squared t. So to simplify this a bit more, so dy over dt equals to 2 tan t. Sec squared t is the same as saying 1 over cos t. So this is the same as saying over cos squared t. Right, so we know that dy over dx, okay, that equals to dt over dx multiplied by dy over dt. So we need to find the inverse of dx over dt. So the inverse is basically just 1 over our differentiated function, okay? So dt over dx, that equals to 1 over negative 4 sine 2t. So therefore, our dy over dx, that equals to dy over dt times dt over dx, which is 2 tan t divided by negative 4 sine 2t multiplied by cos squared t. And that's our dy over dx. And now our next step is just to substitute the point t equals to pi over 4 to find our gradient. So dy over dx, that equals to 2 tan of pi over 4 divided by negative 4 sine of 2t. So 2t is pi over 2. So sine pi over 2 cos squared of pi over 4. And once again, it's just a bit of calculator work. So just substitute all the numbers in radians. It has to be in radians. So tan pi over 4 becomes 2 over sine pi over 2 negative 4 times of cos pi squared. Should be 2 over negative 2. And that gives us an answer of a negative 1. And that will be our gradient at t equals to pi over 4. And this question is a merit level question. So getting up to your final answer, your negative 1 here is a merit grade. To get an achieved grade, you're getting either correct dx over dt or dy over dt. So the marking schedules tells me that either this or this will get you an achieved grade. So either dx over dt or dy over dt, that's good enough for an achieved grade. Alright, so question D, the tangents. Alright, so now looking at question D, the tangents to the curve y equals to 1 over 4 bracket x minus 2 squared at points P and Q are perpendicular. Q is the point 6, 4, so what is the x coordinate of P? So in this case, once we see the word perpendicular, we know that P and Q are normals, or like Q is the tangent. They're both tangents to the graph, but to each other they're normals, which means that when we multiply the gradients together, we'll get negative 1. Alright, so right now we have the point Q is 6, 4, so we can use the gradient function in order to deduce the gradient of line P. And once we find the gradient of line P, we can find the gradient of line P. And once we find the gradient of line P, we know that the gradient of the graph at P is the same as the gradient of P at P. Well, the gradient at line P at P as well. So they're the same. So we can make them equal to each other and we'll find our x point there. So our function is y equals to 1 over 4 x minus 2 squared. We need to go to our gradient function, and we can do that by using the chain rule again. So in this case, the outer function is to the power of 2 on the outside, and the inner function is just x minus 2. So dy over dx, okay, so we're going to say 2 times of 1 over 4 is 1 over 2 times of x minus 2. Power was 2, bring it down by 1, becomes to the power of 1. And we multiply by the derivative of the inner function. The derivative of x minus 2 is just 1. So dy over dx equals to 1 over 2 x minus 2. Alright, to find the gradient of line Q, we need to substitute the point 6, 4. So we need to substitute x equals to 6 to find our gradient. So dy over dx equals to 1/2 times of 6 minus 2, which is equal to 6 minus 2 is 4 times 1/2 is just 2. So we know that our normal gradient multiply to negative 1. So normal gradients multiply to negative 1. So therefore, we can say xn, we'll call xn multiplied by 2 equals to negative 1. Therefore, xn equals to negative 1 over 2. So the gradient of the graph, the gradient of the line P is negative 1/2. All we need to do now is find when on the graph is the gradient negative 1 over 2. So we'll make negative 1 over 2 equal to the gradient function in order to find when the graph has a gradient of negative 1/2, because that's when they will meet. So we can say that negative 1/2 equals to 1/2 of x minus 2. Negative 1/2 divided by 1/2, that's negative 1, so negative 1 equals to x minus 2. Therefore, x equals to negative 1 plus 2, which is just 1. So x equals to 1 should be our final answer for this question. And this is a merit level question. To get an achieved grade, achieved is if you can find your xn equals to negative 1/2, that will get you an achieved grade. Question E, a curve is defined by the function f of x equals to e to the power of negative bracket x minus k to the power of 2. Find in terms of k the x coordinate for which the second derivative is 0. Right, in this case, we need to we have to differentiate twice to find f double dash of x and then make it equal to 0 and then find x in terms of k. Alright, so f of x, Alright, so f of x equals to e to the power of negative bracket x minus k to the power of 2. And we know if we're trying to differentiate e to something, we can just, the e stays the same, but we can just multiply by the derivative. So f dash of x that equals to, so in this case we'll be using the chain rule again. So in this case, if we're trying to differentiate this, we'll get that the outer function is to the power of 2, and the inner function is x minus k. So we should get that negative 2 times of x minus k to the power of 1 multiplied by the derivative of x minus k, in this case it's just 1, times of e to the power of negative x minus k to the power of 2. So f dash of x equals to negative 2x plus 2k bracket e to the power of negative x minus k squared. Alright, to find the second derivative, in this case we're going to have to use the product rule now because we have two functions involving x together. So we're going to be using the product rule. Well, we're going to be using the product rule with the chain rule together. So f double dash of x, that equals to. So in this case, if we do negative 2x plus 2k first, the derivative of negative 2x plus 2k is just negative 2. So this becomes negative 2 e to the power of negative x minus k squared. And we need to add it on to the derivative of e to the power of negative bracket x minus k squared multiplied by negative 2x plus 2k. So we know the derivative of negative bracket x minus k to the power of 2. We know the derivative of that is just negative 2x plus 2k. So you can say this will be plus negative 2x plus 2k squared e to the power of negative bracket x minus k squared. Alright, so we can actually factor out e to the power of negative bracket x minus k to the power of 2. We can factor it out. So f double dash of x equals to e to the power of negative x minus k to the power of 2 bracket negative 2 plus of negative 2x plus 2k squared. And we want to find, in terms of k, the x coordinates for when f double dash of x is 0. So we'll substitute f double dash of x is 0. So we'll substitute the second derivative as 0. However, we also know that e to the power of anything, so let's just say e to the power of x cannot be 0 because something to the power of something else can never be 0. Okay, it approaches 0, it gets closer and closer to 0, but it never actually goes to 0, which means that e to the power, so this here, it cannot be equal to 0. So this cannot be equal to 0. So therefore, we're going to say that we're going to say that negative 2 plus negative 2x plus 2k squared equals to 0. So in this case, we can move negative 2 to the other side. So we can say 2 is equal to negative 2x plus 2k squared. Alright, so at this stage, what we can do, we can actually, Alright, so we'll expand it out. Okay, so we'll say 2 equals to 4x squared. Plus 4k squared minus 8kx equals to 2. So therefore we have 0 equals to 4x squared minus 8kx plus 4k squared minus 2. Now we'll use the quadratic formula now. So we'll say that negative b plus or minus square root of b squared minus 4ac over 2a. Our negative b in this case, it'll be negative 8k. So b is negative 8k. That's b. A is just 4, so that's A, and C is this whole thing here, which is 4k squared minus 2. So x equals to negative b, which is 8k plus or minus square root of 64k squared minus 4 times of a, which is 4, times of c, which is 4k squared minus 2, all divided by 2a, which is 8. X equals to 8k plus or minus square root of, so calculator. So we'll have 64k squared minus 16 times 4k squared minus 2. So 16 times 4k squared minus 2, what is that? That gives us 64k squared, 64 squared, k squared minus 32. So we can replace that for 64k squared minus 32 all over 8. So x equals to 8k plus or minus square root of negative and negative, so it's 32 over 8. So therefore x equals to k plus or minus 32 over 8. We can take the what can we take? We can take a 4 out. So 4 square root of 2 over 8. So therefore x equals to k plus or minus root 2 over 2. Alright, so it should be, so we should have x equals to k plus or minus root 2 over 2. What the marking schedule has here is x equals to k plus or minus 1 over root 2. But if you rationalize it, you'll get the same answer. So you get x equals to k plus or minus root 2 over 2. So it's the exact same thing. So getting up to this step here, so the final answer here will get you an excellence grade. So that's an excellence grade for getting to the final answer. To get a merit grade, you need to find the correct second derivative. So the correct second derivative is up to here. So if you can find the correct second derivative, that's a merit grade. To get an achieved grade, if you can just find the first derivative, you'll get an achieved grade. So finding f dash of x, so that's here, that will get you an achieved. Alright, so question 2, differentiate f of x equals to x ln of 3x minus 1. So in this case, we're going to be using the product rule because we have two functions. So one is x, so function 1 is x, and function 2 is ln of 3x minus 1. So f dash of x equals to, derivative of x is just 1, so ln of 3x minus 1, added on to the derivative of x, sorry, not derivative, multiplied, so x multiplied by the derivative of ln of 3x minus 1, which is 3 over 3x minus 1. So f dash of x is ln of 3x minus 1 plus 3x over 3x minus 1. That should be your final answer there. So that should be just an achieved question here, so achieved. Find the gradient of the tangent of a function y equals to square root of 2x minus 1 at the point 5, 3. Find the gradient of the tangent, so gradient means you have to differentiate, so dy over dx. Well, first we're going to rewrite this. Okay, we're going to rewrite the function first with y equals to 2x minus 1 to the power of 1/2. And this time I'm going to be using the chain rule again. So dy over dx, that equals to 1/2 times 2x minus 1 to the power of negative 1/2 multiplied by the derivative of the inner function, which is just 2. So therefore dy over dx equals to 1 over square root of 2x minus 1. Find the gradient at the point x equals to 5, so dy over dx equals to 1 over square root of 2 times of 5 minus 1, which equals to square root of 9, which is 1 over 3. So 1 over 3, that should just be another achieved question if you can get the final answer. Alright, so question C, the graph below shows the function y equals to f of x, and for the function y equals to f of x above, find the values of x that meet the following conditions. F of x is not continuous, so for places that are not continuous is here, and that's because actually it's defined, so basically f of negative 1 is 5, but therefore it's not continuous. For this point here, it's not continuous either because they're not connected. Or basically, if it's not continuous, the lines are not connected, or if you see a white dot, that's not continuous either. So there's only 2 points in this case, so that would be x equals to 1, x equals to negative 1. f is not differentiable. So not differentiable when it's not continuous, and when there's sharp corners. That's when it's not differentiable. So if there's a sharp corner at x equals to -2, there's a sharp corner at x equals to 4, and we have to come back to our two non-continuous places as well. Those are not differentiable either. So x equals to -2, x equals to -1, x equals to 1, x equals to 4. F dash of x equals to 0, so basically the gradient function equals to 0, so that's when you see the flat line, okay, that's when the rate of change is 0. So looking at the graph here, we have one turning point here, so that's x equals to -4. We also have this turning point here, so x equals to 3, and we also have the straight line here, so the straight line y equals to 3 straight line here. So this arrow means it just keeps going, so basically x is greater than 4. That will be our 3 points, okay? So x equals to -4, x equals to 3, x is greater than 4. Question 4, f double dash of x is smaller than 0. So basically that's asking us for a concave down. So whenever you see it's something, if the second derivative is less than 0, you're looking for the sad face. If it's greater than 0, you're looking for the happy face. Sorry about that. So if looking at the sad face right now, so we're going to be seeing this is if you continue, if this graph is continued, we'll see the sad face here. So that will be when our graph is concave down. So it's between the points of x equals to 4 and x equals to 1, but they're not equal to x. But it's not x equals to 4 or x equals to 1, because you cannot differentiate at x equals to 1 or x equals to 4. So it's only going to be between x equals to 4 and x equals to 1. So f double dash of x is less than 0. It is between 4 and 1. Alright, so it's not equals to, so this will be wrong, okay? The reason that we can't put equals to is because, once again, you cannot differentiate at x equals to 1 or x equals to 4, because it is either not continuous or there's a sharp corner, so you can't differentiate at x equals to 1 or x equals to 4. Therefore, you cannot put the equal signs there. That will be wrong. So the correct answer is x is between 4 and 1. Question II, what is the value of the limit when x approaches -1 of the graph f of x? So at -1, we see that both graphs will be approaching, even though the value is not -1, even though the value is not 1, both sides of the graphs are approaching to the same value, which means that there is a limit. And in this case, it will be the value that both sides are approaching to. In this case, both of the graphs are approaching towards 1, so therefore the limit is 1. Alright, so for this question, 3 correct answers can get to this total of 5 answers. So if you can get 3 out of 5, 3 out of 5 is a merit grade, and 2 out of 5 is an achieved grade. A large spherical helium balloon is being inflated at a constant rate of 4,800 centimeters cubed per second. At what rate is the radius of the balloon increasing when the volume of the balloon is 288,000 pi centimeters cubed? Alright, so first things first, with these, automatically you can see if this is a rate of change question. So the first thing, the very important thing you should always do when you see the rate of change questions is write down what you have and what you need to find and what you need in order to get what you need, okay? So first things first, we write down what we have. So being inflated at a constant rate, the volume is increasing at 4,800 centimeters cubed per second. So dV over dt equals to 4,800. That's the first thing we write down. What is the question asking us? What is the rate of the radius of the balloon increasing when the volume is 288,000 pi centimeters cubed? So the rate of the radius, so rate always refers to dr over dt. So in this case, the rate of change of the radius is what we're trying to find. So now we can say that dr over dt, that equals to dv over dt, that's something we have, multiplied by something else. So in this case, in our dr over dt, there's no dv, so we need to get rid of the dv, so multiply by dv at the bottom here. And we need to introduce the variable dr, so we're going to place the dr at the top here. So dr over dv is what we're trying to find. And we know that the volume of the volume of a sphere is 4 over 3 pi r cubed. So therefore, if we differentiate this formula, so we get dv over dr, that equals to, so that's really easy, just the power rule. So 4 over 3 times 3 is 4 pi r. 3 minus 1 takes the power down by 1, so 3 becomes 2, so dv over dr is 4 pi r squared. However, the question we need is dr over dv, and we have dv over dr, so we just need to invert it, okay? So dr over dv equals to 1 over 4 pi r squared. Therefore, we have our dr over dt equals to 4,800 multiplied by 1 over 4 pi r squared. So dr over dt, that equals to 4,800 divided by 4, that's 1,200 over pi r squared. Alright, so what is the rate of the radius of the balloon increasing when the volume of the balloon is 288,000 pi centimeters cubed? So we'll substitute the volume is 288,000 pi to find the radius at that point. Okay, so 288,000 pi equals to 4 over 3 pi r cubed. Pi and pi cancel each other out, and 288,000 divided by 4 over 3 to the power. Alright, so it should come out to be, radius should come out to be 60 centimeters. And once we have our radius, we can substitute that back into our dr over dt formula in order to find the rate of change. So dr over dt equals to 1,200 divided by pi times of 60 squared. So 60 squared times pi, 60 squared times pi, 1,200 divided by. So we should get that our dr over dt, that equals to 0.106, and we cannot forget the unit. So in this case, our radius is measured in centimeters, and our time is in seconds. So basically, our our unit would just be centimeters per second. This is a merit level question. First one actually merit level question. And if you can get the correct solution, that will be a merit grade. To get an achieved grade, you need a correct expression for dr over dt. So dr over dt, that's up to this step here, will get you an achieved. Question E, a cone of height h and radius r is inscribed as shown inside a sphere of radius 6 centimeters. The base of the cone is s centimeters below the x-axis. Find the value of s which maximizes the volume of the cone. First thing first, we'll write down the formula for the volume of the cone, which is V equals to 1 over 3 pi r squared h. Alright, so first things first, we can already see what our h value is. Our h value is this straight line here. We know that the radius is 6 of the radius of the sphere is 6, so this length is 6 plus of s. Okay, so therefore our height is equal to 6 plus s. And now we need the formula in terms of s for our radius. But if you can see here, we can draw a line. Sorry, my line isn't very good, but we can draw a line from here. And we know that any point from the center of the sphere to its circumference will be the radius of that sphere. So we know that this line has a length of 6 centimeters. Or is it centimeters? Yes. So we know that line has a length of 6 centimeters. We know that this base here is the radius, and we know that that small height there is s. So therefore, by using Pythagoras theorem, we can say that r squared plus s squared equals to 36. And therefore, 36 minus s squared square root equals to r. So therefore, if we substitute r in terms of s and h in terms of s into our volume formula, so we get v equals to 1 over 3 pi r squared. R squared is just 36 minus s squared times of height, which is 6 plus s. So volume equals to 1 over 3 pi, and we'll just we'll simplify this as 216 plus 36s minus 6s squared minus s cubed. Volume equals to 1 over 3 pi, so we have negative s to power 3 minus 6s squared plus 36s plus 216. Alright, so v equals to we can expand it out. So it's 3 pi minus 6 times 1 over 3 is just 2, so minus 2s 3 pi plus 36 times 1 over 3 is 12, so plus 12 pi s plus 216 divided by 3 is 72 plus 72 Okay, so now we can differentiate. Okay, so dv over ds, that equals to. Okay, so negative s cubed divided by 3. So 3 times of 1 over 3 is just 1, so it becomes negative s squared pi minus 4s pi plus 12 pi. And we notice that we can factor out the pi now, so dv over ds equals to pi times of negative s squared minus 4s plus 12. And we know that at a maximum or minimum, the derivative is equal to 0. So therefore, 0 equals to pi negative s squared minus 4s plus 12. And therefore, negative s squared minus 4s plus 12 equals to 0. Alright, at this stage, you can just go directly to your graphics calculator. So polynomial degree 2. We should get that s equals to 2 or s equals to negative 6. But you can say that s is not negative, so we can say that s is strictly positive. So therefore, it cannot be s equals to negative 6. Therefore, s equals to 2. So we can say s equals to 2 centimeters. And that will be our final answer for that question. So to get a correct solution here, s equals to 2 will get you an excellence grade. To get a merit grade, you need a correct expression for dv over ds. So dv over ds found it correctly, so that's here, will get you an merit grade. And there's actually no criteria for an achieved grade. So for this question, you can only get a merit or an excellence grade. You cannot get an achieved grade. Alright, so question 3, differentiate f of x equals to the 4th root of 3x plus 2. So we're going to rewrite this as to the power of 1/4 instead. So f of x equals to 3x plus 2 to the power of 1 over 4. If we differentiate this, we get f dash of x equals to bring the power down, so 1/4, 3x plus 2, 1/4 minus 1, bring the power down by 1, so negative 3 over 4, multiplied by the derivative of the inner function. Derivative of 3x plus 2 is just 3. So this equals to 3 over 4, 3x plus 2 to the power of negative 3 over 4. And this is just an achievable question. Question B, find the x value at which a tangent to the curve y equals to 6x minus 3 to... What am I saying? Find the x value at which a tangent to the curve y equals to 6x minus e to the power of 3x is parallel to the x-axis. Alright, so when the question tells you parallel to the x-axis, you can draw a picture in your head, and you can automatically see that if it's a parallel to the x-axis, then it has to be gradient equals to 0. So, in order to find the point where the gradient equals to 0, we need to differentiate. So y equals to 6x minus e to the power of 3x. Therefore, dy over dx equals to 6 minus, with e, the derivative of 3x is 3, so 3 multiplied by 3. 3 multiplied by e to the power of 3x. Find the x value which is parallel to the x-axis, so we substitute dy over dx equals to 0. So 3 e to the power of 3x equals to 6. So therefore e to the power of 3x equals to 2. And therefore 3x equals to ln of 2. And x equals to ln of 2 over 3. And if you want to convert that to decimal form, it doesn't really matter. But if you want to convert to decimal form, that is approximately 0.231. And that is another achieved question there. It's achieved. Question C. A rectangle has one vertex at 0, 0, and the opposite vertex on the curve y equals to x minus 6 squared, where x is between 0 and 6, as shown in the graph below. Find the maximum possible area of the rectangle. Alright, so this question, we know that the y value here, so the height of this rectangle is just equal to the y value of the parabola, so that's y. And we know that the base of this rectangle is just equal to whatever x value it is. So what we know is that area equals to base times height, and therefore area equals to x times y. But we know y equals to x minus 6 whole squared. Okay, so a equals to x times of x minus 6. So x minus 6 squared. Find the maximum possible area. Okay, so once this is our area formula, and we can just differentiate. So for this question, like many people might choose to expand everything out and then distribute to x, but however that takes a lot longer. You rather just use the product rule straight away, and find the answer much quicker. So the product rule, we have x and x minus 6 squared, so dA over dx, that equals to x minus 6 squared, because the derivative of x is just 1, multiplied by 2x times of x minus 6 to the power of 1 multiplied by 1. And that's because we want to find the derivative of x minus 6 to the power of 2, so we move the 2 down, becomes 2x multiplied by x minus 6 to take the power down by 1 multiplied by 1. Alright, so now we have dA over dx, and we know that at a maximum area, the derivative is equal to 0. So 0 equals to x squared minus 12x plus 36 plus 2x squared minus 12x. So 0 equals to x squared minus 12x plus 36 plus 2x squared minus 12x. Okay, so therefore 0 equals to negative x squared minus 24x plus 36. And once again, we can just go straight to our graphics calculator. So it's polynomial. Alright, so we should get interesting. So we should get x equals to 1.4164 or x equals to negative 25.416. And we need to find the maximum possible area, so we'll substitute that back in. So we'll substitute A equals to 1.4164 multiplied by 1.4164 minus 6 squared. Because we know that x cannot be negative, so we can say x is greater than 0. Therefore, x is not equal to negative 25.46. Okay, so may have made a mistake here, so hold up. Oh yes, I apologize. I have indeed made a mistake. Okay, so we have positive x squared here and positive 2x, and I subtracted them. So I apologize for that. So this is not right. Apologize for that. I apologize. Okay, so what we actually have here is 0 equals to x squared plus 2x squared, which is 3x squared, minus 24x plus 36. If 0 equals to 3 multiplied by x squared minus 8x plus 12. So 0 equals to 3 times of x minus 6, x minus 2. So therefore x equals to 6 or x equals to 2. Alright, so it says you do not need to prove that the area found is the maximum. But if we go back to the diagram here, we have 6, but it's to the right of the rectangle, which means that x must be strictly lower than 6. So x must be lower than 6, which means that this is not valid. X equals to 2. So therefore, area equals to 2 times of 2 minus 6 whole squared. 16 times 2, that's 32. So this equals to 32 units squared. And this is a merit level question there. Merit for the correct answer is merit. For an achieved grade, all you need to have is a correct derivative. So correct derivative. So if you get up to a correct derivative here, that's an achieved. Alright, so once again, I apologize for making that mistake. It's pretty stupid, but I apologize. Alright, so question D, if y equals to e to the power of x over sine x, show that dy over dx equals to y times of 1 minus cotangent x. For this question, we have something over something else. We can just use the quotient rule. So y equals to e to the power of x over sine x. Okay, so quotient rule says that we're going to have the numerator is the derivative of the numerator multiplied by the denominator minus the derivative of the denominator multiplied by the numerator divided by the denominator squared. So y equals to e to the power of x times of sine x, and that's because the derivative of e to the power of x is still e to the power of x, and minus derivative of sine x is cos x multiplied by e to the power of x divided by sine squared x. Alright, so at this stage we can actually say y equals to e to the power of x sine x minus cos x over sine squared x. And that's just factoring out the e to the power of x. Okay, we factor out e to the power of x, we get e to the power of x times sine x minus cos x. And furthermore, we can actually say y equals to e to the power of x multiplied by sine x. Okay, that's going to be our y. As you can see here, I'm trying to set up the y value back. Okay, so I'm going to take one sine from the denominator and move it to just move it separately. So this multiplied by sine x minus cos x over sine x. Right, so y equals to e to the power of x sine x multiplied by sine x over sine x is 1 minus cos x over sine x. We know cos over sine is cotangent, so therefore y equals to e to the power of x over sine x multiplied by 1 minus cotangent of x. Right, but we know that, sorry, this is dy over dx. Why am I? Okay, dy over dx. Okay. Dy over dx. Okay. But we know that e to the power of x over sine x, that equals to y. So therefore dy over dx, that equals to y multiplied by 1 minus cotangent x. And you can say as required, or QED. And this will be a merit level question to get and achieve this correct expression for dy over dx. So dy over dx is correct, that will get you an achieved. Alright, so this last question here in the rugby game, a try scored 15 millimeters from the left-hand goal post. The conversion kick was taken at some point on the line perpendicular to the goal line from the point where the try was scored as shown in the diagram below. The ball needs to pass between two goal posts, which is 5.4 meters apart. Find the distance d from the goal line that the conversion kick should be taken in order to maximize the angle theta between the lines from the ball and the goal posts. Right, first things first, we're going to be setting up our equations for our angles, okay? So we know that tan alpha, first we know is tan alpha equals to 15 over d. And we know that tan alpha plus theta, that equals to 15 plus 5.4 over d. This equals to 20.4 over d. Alright, so we can go back to our, on our formula sheet, there is a way we can convert two angles added together into two angles separately, okay? So that should be, so basically tan A, my writing is not neat, okay, so tan A plus or minus B, that equals to tan A plus or minus tan B over 1 minus or plus tan A tan B. Alright, so we can use that formula in order to get rid of the alpha plus theta and put it as just one angles by itself. So therefore we can say that tan alpha plus theta equals to tan alpha plus tan theta over 1 minus tan alpha tan beta. But one important piece of information we know is that tan alpha is 15 over d. So we're going to plug that in. Okay, so tan alpha plus theta equals to 15 over d plus tan theta over 1 minus 15 over d tan theta. But we know that, but we also know that tan alpha plus beta equals to 20.4 over d, and we'll plug that in instead. So 20.4 over d equals to 15 over d plus tan theta over 1 minus 15 over d tan theta. And we can actually do a cross multiplication. Okay, so cross multiplication we get 20. Sorry, we'll just separate this. Okay, so we get 20.4 multiplied by 1 minus 15 over d tan theta. That equals to 15 over d plus tan theta multiplied by d. Right, and this actually gets us to 20.4 minus, what's 15.4 times 20.4? Minus 306 over d tan theta. That equals to 15 plus d tan theta. Alright, so at this stage, okay, we can actually we can actually move the 15 to the other side. So 20.4 minus 15 is just 5.4, and that equals to d tan theta plus 306 over d tan theta. At this stage, we can actually factor out tan theta. So 5.4 equals to tan theta and that's d plus 306 over d. Therefore, tan theta equals to 5.4 over d plus 306 over d. Alright, so let me go to another page here. So what we had there was tan theta equals to what was it? Oh, my short-term memory. 5.4 over d plus 306. Okay, so 5.4 over d plus 306 over d. Alright, at this stage, we actually have to look at the graph of tan theta. Okay, so we look at roughly just a rough sketch of tan theta. It looks something like, okay, that's not a good drawing, sorry. So tan theta should look, sorry, I'm not very good at drawing it, but yeah, our tan theta graph looks something like that. Okay, as you can see, the limits are from negative infinity to positive infinity, so any real number. So in this case, we can actually see that our maximum occurs when the derivative of tan theta equals to 0. So we actually can just say the derivative of tan theta over d over the distance, that equals to 0. Alright, so in order to find the derivative, we're going to be using the quotient rule because we have something over something else. So derivative of 5.4 is just 0, so there's not going to be anything in front, so therefore it will be negative 5.4 multiplied by the derivative of d plus 306 over d. So that becomes 1 plus of 306 over d differentiates to negative 306 over d squared. So that's our function that equals 0. Therefore 0 equals to negative 5.4, 1 minus 306 over d squared. 0 equals to negative 5.4 plus 306 over d squared. So what we have here is 5.4 d squared equals to 306. Where am I? 504. Oh yes, far. Oh my. Okay, so 306 times of 5.4. Forgot about that. Times 5.4. Apologize. Times 5.4. 5.4 times 306. Okay, so 5.4 here, 5.4 that cancels out. So d squared equals to 306. Therefore, d equals to the square root of 306, which is 17.49 meters. And that will be our final answer for this question. Alright, this is actually an excellent level question and T grade for the correct answer. For a merit grade, we're looking at a correct expression for what is it saying? So tan theta over dd. So correct expression, so correct derivative is a merit. That's pretty tough, but correct derivative is a merit. To get an achieved, there's actually no achieved criteria, so you can only get a merit or an excellence grade for this question. So alright, so one thing I didn't really like about this question was how you had to look at the graph of tan theta and then make a conclusion that the derivative of tan theta, when derivative of tan theta is 0, that's when the maximum occurs. That's that'll be really difficult if you didn't know what the graph looked like, and therefore I think there'll be a better way to do this question. I'll show you this right now, okay? So just like a mini lesson here. So starting from the very start, we had tan theta equals to 15 over d, and then tan alpha plus theta equals to 20.4 over d. Let me just double check that. So okay, yes. And if you notice that we can take the tan inverse of both sides, the tan inverse of 15 over d, so that's alpha. And we can say that tan inverse of 20 over 4 over d, that equals to alpha plus theta. But we know alpha is equal to tan inverse of 15 over d. So therefore, theta equals to tan inverse of 20.4 over d minus tan inverse of 15 over d. Alright, so the derivative of tan inverse, okay, I'll show you the derivative of tan inverse right now. So in order to find the derivative of tan inverse, we're going to be using implicit differentiation. So that's where we can say tan inverse of x equals to y. So y equals to tan inverse of x. We can take we can inverse tan of both sides again, so that becomes tan y equals to x. And if we differentiate both sides implicitly, we'll get sec squared y multiplied by dy over dx. That equals to the derivative of x, which is just 1. Therefore, dy over dx, that equals to we'll simplify the sec squared x first. So sec squared y, So 1 over cos squared y times of dy over dx, that equals to 1, right? And we can actually multiply both sides by cos squared y. So we get dy over dx equals to cos squared y. Alright, so what actually helps us right now is we know that x equals, we knew that tan y equals to x. So therefore tan y is sine y over cos y. If we squared that and added 1, let's see what we would get. So if we sine y over cos y, that's equal to tan y. So tan squared y plus 1, that will give us sine squared y over cos squared y plus plus 1, so we'll put plus 1. And we can make it into one fraction, so we can say sine squared y over cos squared y plus of cos squared y over cos squared y. And this becomes sine squared y plus cos squared y over cos squared y. And sine squared y plus cos squared y, that's just 1, so this becomes 1 over cos squared y. If we take the inverse of this, we'll get our dy over dx, right? If we take the inverse of this, we'll get cos squared y. So basically, we know that tan y equals to x, right? That's what we do. That's what we do know. So tan y equals to x. So therefore, sine y over cos y is x. So therefore, we have x squared plus 1 equals to 1 over cos squared y. If we take the inverse of it, we'll get 1 over x squared plus 1, that equals to cos squared y, which is the exact same thing as what we have here in our dy over dx. So therefore, we can actually say that dy over dx equals to 1 over x squared plus 1. And that actually becomes very, very useful for us in this question, because we can just immediately find the derivatives of this function straight away. So if we go to the next page here, because I'm running out of space, we knew that theta was equal to tan inverse of 20.4 over d minus tan inverse of 15 over d, I believe. Double check. Yes, okay. So right now for this question, we'll just be using the exact same thing, but we're just using the chain rule again. So in this case, our outer function is inverse tan. We know inverse tan differentiates to 1 over x squared. We know the inner function is 20.4 over d. So the derivative of 20.4 over d is so 20.4 d to the power of negative 1, that becomes negative 20.4 over d squared multiplied by 1 over, instead of having x with d, so this is 1 plus of d squared, but instead of having d squared, we're going to have everything inside the brackets, so 20.4 over d squared minus the derivative of this. And we'll actually get, this one will be, for 15, derivative of 15 over d, that's 15d minus 1, so that's negative 15d squared, that's the derivative. So minus negative 15 over d squared multiplied by 1 over 1 plus of 15 over d squared. And that's our d theta over dd. And this actually gets us negative 20.4 over d squared, right? So d squared, 20.4 over d squared multiplied by 1 over 1 plus of 20.4 squared is 416.16 over d squared plus of 15 over d squared times of 1 over 1 plus 225 over d squared. Alright, so now we can simplify a bit more now. So we can say negative 20.4 over d squared plus, so d squared here and the d squared in the denominator will cancel out. So d squared plus 416.16 plus of 15 over d squared plus 225. And that equals to 0. Alright, so at this stage, we can actually just cross multiply. So 0 equals to negative 20.4 times d squared plus 225 plus 15 times of d squared plus 416.16 and over d squared plus 416.16 multiplied by d squared plus 225. But we know that if we multiply both sides by the denominator, we'll just still get 0 equals to negative 20.4. We'll expand it, so 0 equals to negative 20.4 d squared minus 225 times negative 20.4. 225 times negative 20.4. So we'll get minus 4590 plus 15d squared plus 416.16 times 15. What we actually have right now is we go back to negative 20.4 plus 15, that's negative 5.4 d squared. That equals to, so that's added on to negative 90 plus 6242.4. That is 1652.4. And if we move the 5.4 d squared to the other side, we get 5.4 d squared equals to 1652.4. Divide both sides by 5.4. We'll get back to our equation. D squared equals to 306. And D equals to square root 306, which is 17.49 meters. So as you can see here, if you use this strategy, it's always a guarantee that you can get the correct answer without having to rely on the graph knowledge. So in my opinion, this is in my opinion, I think this is an easier way of doing this question, and it leaves out any of the ambiguity. So if you do wish to use something like this in your actual exam, just to let the marker know what you're doing, just write down that the derivative of tan inverse of x is 1 over x squared plus 1. And it's just basically just gives a brief explanation of what you're doing, so the marker knows what you're doing and can accept your answer. Anyway, so thank you for watching this video. I hope you enjoyed the video, and I hope to see you on the next